Hello, welcome back to our physics lessons. Today we want to talk about pressure, and this is one of the most interesting topics in our Form 1 work, and I believe we are going to go through most of the concepts, and at the end of the day they will appear to be very simple. Now the topic pressure is going to include two of the previous topics that we have already looked at, which is force and measurement, of which under measurement we are going to consider area under the topic pressure, and in force we are going to see how it's going to come into action. So to start with, without explaining much, I want us to check a small video here whereby you'll be able to see something happening. Look at that particular object being pressed on the surface, then that is a push. So this person is applying force, and then on a particular place, on a surface, and that is the area on a given space or on a given surface, which is area. So under that part, we'll be able now to form our minds more particularly on the topic of the day, whereby we have seen force being applied, but it's being applied on a given surface. And when we are very specific, we talk about a given area. So from that part, it now brings us to the definition of the term pressure, which is the topic of the day. As you can see, that was force that was acting on a given surface, and it was perpendicular. So in this case, we're going to give the definition of pressure from what we have already seen, and we'll say pressure is the force acting normally or perpendicularly per unit area. So two things are involved: one, force, and the other one is area. Now this pressure has the standard units, that is the SI units. We have talked about force and we have also talked about area in this definition. Therefore, force has the SI, the units of force are in newtons, and area is measured in square meters. Therefore, if we have this definition, pressure is the force acting perpendicularly per unit area, then we can formulate it and write it as pressure is equal to force over area. Therefore, from this, we can easily determine the SI units of pressure. We can determine the SI units of pressure as the Newton per square meter. Newton per square meter, and you can see how it is abbreviated at this point, or it is the Pascal. So, and as well, we can say that 1 Pascal is equivalent to 1 Newton per square meter. So somebody can give the SI unit of pressure as Newton per square meter or Pascal in terms of Pascal. So this formula that we have said we are going to form from here, from the definition, is going to be pressure is equal to force over area. So you can play around with the formula. If you want to look for force, you can have it as pressure times area. If you want to look for area, it is force over pressure. So that takes us further to the next part of this topic, whereby we are supposed to look at pressure in solids, because as we move on, we'll be able to look at also pressure in all the three states of matter. So we want to start with the first one, which is solids. And in this case, we are talking about pressure in solids. So force exerted by a solid resting on a surface is equal to the weight of the object. The force exerted by the solid resting on a surface is equal to the weight of the object. For example, if we place a book on top of maybe a table, the book which is a solid, will be resting on the table. Therefore, it will be exerting force which is equal to the weight of that particular book. So you can see here we have highlighted some formulas. Pressure is equal to force or the weight of the solid over the area of contact. Then this weight or this force, remember from the topic force, we was able to say that weight is equal to mass times g. So in this case, it will not be a problem for us to determine the weight of an object, provided we have its mass. We can be able to determine its weight. And the area of contact, we are going to look at the area and we'll be able to determine areas of different surfaces so that they can be able to help us determine pressure. Now, sometimes we talk about this pressure being maximum or minimum. And in this case, before I even go through that part, I want to take you through another section whereby we are going to look at this video here. A book being placed on the surface of the table. It exerts a force equal to its weight. I believe that video is very clear. That book that has been placed on top of a table exerts a force which is equal to its weight. And the weight of the book, we know it's mass times the gravity, mg. So in that case, we can now go back to this part and talk about maximum pressure. So to talk about maximum pressure and minimum pressure, we want to look at the variation in the area. The variation in the area. And I believe this one will be highlighted well after we look at the factors affecting pressure in solids, whereby we'll see how the area affects pressure. Therefore, we'll be able now to talk about when pressure is maximum and when pressure is minimum, depending on the area in contact. So this one we'll be able to explain it as we move on. Then now, moving further, we can also look at the factors affecting pressure in solids. And as you can see, one is the weight of the solid, because we have talked about two things in the definition of pressure. We've talked about pressure being the force acting perpendicularly per unit area. So we are talking about force which is acting perpendicularly per unit area. So we have talked about force and area. So the first factor is the weight, which is force. If the area of contact between the solid and is constant, then pressure increases with weight. So the more the weight, the more the pressure. The more the weight, the more the pressure. And can talk about the second one, which is area of contact of the solid with the surface. The area of contact of the solid with the surface. Area of contact of the solid with the surface is also very critical, because the smaller the area, the higher the pressure if the same force is applied. Therefore, if we have a wider area, then the pressure applied is minimum. Therefore, pressure can be reduced by increasing the area of contact. So if we want to talk about increasing pressure, you reduce the area in contact. If you want to reduce pressure, then we are talking about increasing the area of contact, because now the weight will be spread so that it cannot be applied at one point. So now, moving on, we can check the next part, which is now some images here which we have, which are going to help us with the area in contact. Look at the shoes that have been displayed here. Towards my right, or towards your right, you can see high-heeled shoes, very sharp. Look at the area that is in contact with the surface at that tip there. Then to your left, you can see we have flat shoes. Look at those shoes. Then look at how the area in contact is wide. The area in contact is very wide. So now we want to look at where pressure is exerted the most, considering that the weight is constant, and this is the same person using these flat shoes and the high-heeled shoes. Then you note that when the person has used high-heeled shoes, the area in contact with the surface is very small. The area in contact with the surface is very small. Therefore, it leads to increase in pressure. So we are going to get maximum pressure when the area in contact with the surface is very minimum or is very small. And when the shoe or the surface in contact in this left side shoe is wide, then the pressure exerted is minimum. The other one, we have said the pressure exerted is maximum because the area is minimum, very small area in contact. But then when the area in contact is very big, that is a very big area in contact, then we talk about minimum pressure exerted. So this is minimum pressure that is being exerted because of increased surface, that is increased area that is in contact with the surface. While this other one, for the high-heeled shoes, the area in contact is very small, it's minimum. Therefore, the pressure exerted is maximum. Now, that one gives us a very good picture so that you can always remember once you are asked to maybe explain maybe a question from pressure in solids. This applies to when we talk about using a pin. A pin comes into contact with the surface and the area in contact is usually very small, just as these high-heeled shoes, so that you can be able to explain using the factors that we have talked about. And the factor that is being looked at here is the area in contact. Then moving on, we have another image here. Look at the two sets of tires or wheels. The first vehicle, the one to the right, let's start with the one to the right. We only have one wheel, which means that the area in contact with the surface or with the road is very small. And now, due to the weight of this vehicle, then we are experiencing a lot of pressure being exerted. Therefore, it is making such images as we can see. Due to high pressure, the tile has been able to dig through to the ground. But then, once this number of tires are increased to 2, like the image we have on the left, then now you can see the area in contact with the surface has increased. The area in contact with the surface has increased. Therefore, pressure exerted by the weight here, because remember the weight of this vehicle is still applying downwards. So now the pressure exerted will be minimum. That is why it will be minimum. That is why these tires don't crack the road. They don't destroy the road as compared to the one on the right hand side. Because as you can see, the one on the right hand side, the area in contact is very small, and therefore the force applied there is a lot. Therefore pressure exerted at this particular point has increased, or it's the maximum pressure, and this is the minimum pressure. Now, moving from that part, we have a very good question from the area we've just covered, from those images that we have just checked under the factors. Trucks that carry heavy loads have many wheels. We explain. Under this part, we are talking about the image that we have just seen, that trucks that carry heavy loads have many wheels. From this diagram here, we have explained something. All in relation to this, we are talking about the area in contact, the area of contact with the surface. So many wheels increase the area of contact with the ground, thereby reducing pressure exerted on the road. Many wheels increase the area of contact with the ground, thereby reducing pressure exerted on the ground. This prevents damage of the roads by the trucks. This prevents damage by the trucks, damage of the roads by the trucks. I believe to that point we have given a good introduction towards this topic, pressure, and we have already looked at pressure in solids. Now in our next session, we'll now look at calculations involving pressure in solids based on what we have talked about, which is the weight of an object and the area in contact. So thank you for moving all through with us, and I believe in the next session we'll be able to talk more about this topic, pressure. Thank you.